Welcome to the introduction chapter of SQL Fundamentals 1 course presented by Sahai Education. This is Deepak Pal Singh, and in this tutorial I'll discuss the Relational Database Management Systems, also known as RDBMS, and the Structured Query Language, also known as SQL. All organizations store some type of data. For example, a university may store data about its students, courses, and professors. Similarly, a business organization may keep data about its employees, suppliers, orders, etc. Traditionally, this data was stored in individual, unrelated files, sometimes called the flat files. Every application program in the organization maintained its own file separate from the other applications. For example, in the case of a university, each department would maintain a separate file for its data. The recording office would keep a file about the students and their grades. The scheduling office would keep its own file about the professors and the classes they were teaching, and so on. Today, however, all of these individual flat files can be combined into a single entity, the database, for the whole university. A database is defined as a collection of logically related data used by the application programs in an organization. Compared to the flat file system, there are several advantages of a database system. In the flat file system, for example, same piece of information is usually stored in more than one file, leading to duplication of data. In the earlier example of a university, the names of professors and students may be stored by more than one department. The database, in contrast, stores information just once. The reduced duplication significantly reduces the cost of storing information on hard drives or other storage devices. Since the flat file system stores the same piece of information in more than one place, any changes to data need to occur in all the places that the data is stored to maintain data integrity. The chances of making a mistake in this case are higher than if you were to make the change in a single place. Databases help maintain data integrity because updates and changes to data only have to be made in one place. The databases make it easier to maintain the security of the information since the storage of data is centralized in a single location. And finally, it is easier to access and manipulate data in a database than using flat files. Just to quickly wrap up what we have learned so far, a database is a collection of logically related data. Compared to the flat file system, databases reduce duplication of data, improve security, and are more user-friendly. In the next section, we define the database management systems. A database management system, also known as DBMS, is the software that creates and manages a database on your behalf. It automates the storage, retrieval, and manipulation of data in the database and also controls user access. The American National Standards Institute, also known as ANSI, has established a three-level architecture for the database management systems. The objective of this three-level architecture is to separate the user's view of the database from the way that it is physically stored. The internal level determines how the data is actually stored on the storage devices. This level deals with low-level access methods and how bytes are transferred to and from storage devices. The conceptual level defines the organization's view of the database, that is, the logical structure and appearance of the database without any concern for how it is physically stored. Thus, the conceptual level acts as an intermediary and frees the users from dealing with the internal level. The external level defines the view of an individual user of the database. This view is often a restricted view of the database, and the same database may provide a number of different views for different classes of users. In general, the end users and even the application programs are only interested in a subset of the database. For example, a department head may only be concerned with the departmental finances and student enrollments, but not the library information. Similarly, a librarian would not be expected to have any interest in the information about the academic staff. How the data is laid out at the conceptual level is defined by means of a database model. In the history of database design, three models have been in use: the hierarchical model, the network model, and the relational model. A hierarchical database model is the model in which the data is organized into a set of tree-like structures, also known as hierarchies. The tree structure allows representing the information using parent-child relationship, where each parent can have many children, but each child has only one parent. This is also known as one-to-many relationship. Here, the department records are linked to the courses and students in a one-to-many relationship. Similarly, the courses are linked to the professors teaching them. Hierarchical databases were popular through 1970s. Another database model popular during 1970s was the network model, which was invented as an enhancement of the hierarchical model. In a network database model, the data is organized into a set of network-like structures. In a network structure, each parent can have many children, and each child can also have many parents. This is also known as many-to-many relationship. For example, a department may be linked with courses, students, and professors in many different ways. The relational database model was proposed by Dr. E.F. Cord in a June 1970 paper titled A Relational Model of Data for Large Shared Data Banks. In the relational model, the data is organized into a set of two-dimensional tables, also known as relations. Relational databases have become the de facto standard, replacing the hierarchical and network models in the mainstream DBMS market because of their ease of use and flexibility. Here, we have four relations belonging to a university database. The tables are related to each other, but unlike the hierarchical and network models, there are no physical links. Instead, the data in two tables is related through common columns. Each relation in a relational database appears as a two-dimensional table. This does not mean that the data is stored as tables. The physical storage of the data is independent of the way in which it is logically organized. A relation has the following features. Each relation in a relational database has a name that is unique among the other relations. The columns in a relation are called its attributes. The rows in a relation are called tuples. The tuple is a collection of attribute values across a given row. In a relational database, we can define several operations to create new relations based on existing ones. We define 9 operations in this section. The first operation, insert, is a unary operation, that is, it is applied to a single relation. This operation adds a new tuple into the relation. The update operation is also a unary operation that is applied to a single relation. This operation changes the value of one or more attributes in a tuple. The delete operation again is a unary operation. This operation removes a tuple from the relation. The select operation is a unary operation and creates another relation. The tuples in the resulting relation are a subset of the tuples in the original relation. The project operation is also a unary operation. The attributes in the resulting relation are a subset of the attributes in the original relation. The join operation is a binary operation that combines two relations based on common attributes. Here, we combine the course and student relations based on the common attribute course number. As shown, the resulting relation has attributes from both relations. The union operation takes two relations and creates a new relation which is the union of the two. In other words, the resulting relation contains tuples from both relations, skipping any duplicates. The intersection operation takes two relations and creates a new relation which is the intersection of the two. That is, only the tuples common to both relations are included in the resulting relation. The difference operation is applied to two relations. The resulting relation contains tuples that are in the first relation but not the second. To wrap up, a database management system is the software that manages the database on your behalf. The ANSI has established a three-level architecture for the database management systems. The internal level defines how the data is physically stored. The conceptual level defines the logical appearance of the database, and the external level defines a user's view of the database. Three types of database models have been in use to determine how the database is laid out at the conceptual level: the hierarchical model, the network model, and the relational model. The relational database model is the most popular of these and organizes data in the form of tables consisting of rows and columns. There are 9 operations to create new relations based on existing ones. In the next section, we explore the database design process. The database design process consists of deciding what tables to create, what columns they will contain, as well as the relationships between the tables. While it would be nice if this process was easy and obvious, or even better automated, this is simply not the case. The design of any database is a lengthy and involved task that is done through a step-by-step process. The first step involves interviewing the potential users of the database to understand their needs. The second step is to build an entity relationship model based on the user requirements. In the third step, we create the database tables based on the ER model. And the final step is to refine the database tables to remove duplication and ensure that the data dependencies are correct. Let's have a look at these steps in a bit more detail. After gathering the user requirements, the next step is to create the entity relationship model. The ER model defines the entities for which information needs to be stored. It also defines their attributes and the relationship between the entities. The database designer represents the ER model by way of an ER diagram. The ER diagrams use several geometric shapes, but we will only use a few of them here. Rectangles represent entities. Ellipses represent attributes of the entities. Diamonds represent relationship between the entities, and lines link the attributes to entities and entities to relationships. Here is a very simple university ER diagram with 3 entities, their attributes, and the relationship between the entities. As shown, each entity has a key attribute, which is the unique distinguishing characteristic of the entity. For example, the ID number is a student's key attribute. Once the ER diagram has been finalized, relations or tables can be created in the relational database. For each entity in the ER diagram, we create a table in which there is one column for every attribute defined for that entity. Besides entities, we also create a table for every relationship in the ER diagram. The relationship table has one column for the key attribute of each entity involved in that relationship. There are two relationships in the ER diagram, each connected to two entities. The tables for these relations are added to the previous tables for the entities. Normalization, which is the final stage in database design, is the process by which a given set of tables is transformed to a new set of tables with a refined structure. There are two goals of the normalization process: eliminating the redundant data, for example, reducing the occurrence of same data in more than one table, and ensuring data dependencies make sense, that is, only storing related data in each table. Both of these are worthy goals as they reduce the amount of space a database consumes and ensure that the data is logically stored. The database community has developed a series of guidelines for normalizing a database. These are referred to as the normal forms and are numbered from 1 through 5. In practical applications, you will often see the first, second, and third normal forms. Fourth and fifth normal forms are rarely used. The discussion of the normal forms is outside the scope of this course and is left to the books dedicated to the database topics. The database design process completes once the relations have been normalized. To summarize, the database design process consists of interviewing the users of the database to understand their needs, building an entity relationship diagram to represent those requirements in the relational model, and finally, creating the database tables based on the ER model. The tables can be refined through the process of normalization to remove duplication and ensure that the data dependencies make sense. Let's take a look at the relational database market next. Oracle was the first company to offer commercial RDBMS in 1979. Since then, Oracle has consistently maintained its lead in the RDBMS market. According to the Gartner 2007 report, Oracle is the world leader in RDBMS market with a revenue share of 47%. Oracle is followed by IBM DB2 and Microsoft SQL Server with 21% and 17% shares respectively. Oracle is an American multinational corporation headquartered in California that specializes in developing and marketing computer hardware systems and enterprise software products, particularly the relational database management systems. Larry Ellison, a co-founder of Oracle Corporation, has served as Oracle's CEO throughout its history. As of 2011, there were more than 100,000 employees working for Oracle worldwide. Let's have a look at the structured query language now, popularly known as SQL. SQL is the language standardized by ANSI and the ISO, using which users and applications interact with the relational databases. Application programs and Oracle tools often allow access to the database without using SQL directly, but these applications in turn must use SQL commands when executing user requests. SQL is a declarative rather than a procedure language. What this means is that the users declare what they want without having to write a step-by-step procedure like in some other programming languages such as C. The SQL language was first implemented by the Oracle Corporation in 1979, with various versions of the language being released since then. Based on the functionality, SQL commands are subdivided into 4 categories. The first category is the data manipulation language and includes commands to access and manipulate the data stored within the tables. The second category is called the data definition language and provides commands to manage the data structures such as tables within the database. So, while DML statements act on the data within the tables, the DDL commands act on the tables themselves. The third category is called the data control language and includes commands to manage the security or access rights to the database. And finally, we have the commands to manage the transactions in the database. By the end of this course, you shall understand and be able to use all of these commands. Oracle provides 2 tools for writing SQL statements. SQL Star Plus is the primary tool for connecting to the database and executing SQL commands. It has a command line interface and offers the most comprehensive support for SQL commands. All SQL statements are supported along with their full syntax. This is in contrast to the GUI tools that often lack the support for full command base. The other available tool is SQL Developer. It is the GUI alternative for SQL Star Plus and is written in Java. It encapsulates the most commonly used SQL functionality into few easy-to-use screens and does help increase the developer efficiency. For functionality not yet supported in the GUI, it also offers a command line interface just like SQL Star Plus. However, even the command line interface lacks full SQL support, and you still need to fall back on SQL Star Plus for commands that do not work in SQL Developer. Both tools are free and come pre-installed with Oracle database and client binaries. We will use SQL Star Plus throughout this course. SQL Developer is quite easy once you know SQL Star Plus and is covered in some detail under Appendix A. In the real world, the choice would depend upon your comfort level and the functionality supported by these tools. To summarize, Oracle is the world leader in RDBMS market. Users and applications interact with relational databases using the SQL language. Oracle provides 2 free tools for developing SQL commands. SQL Star Plus is the primary tool that will be used throughout this course. This brings us to the end of the introduction chapter. In the introduction, we learned about the relational database management systems which store data in form of tables. SQL is the language using which the users and applications access a relational database. The next chapter discusses the most common operation in SQL, that is the select statement.